So the topic on chapter 7 is form work. This is covered by CLO3. Classify the temporary structure such as form work. Okay, classify the temporary structure such as formwork and scaffolding. Today we will see all about formwork and scaffolding in construction. Have you heard about the term before? Never?
No.
Okay. Outcome of last class. Just quickly review on the last class. We did classification of piles based on site conditions. We studied some of the deep foundation piles, right? Classification of piles based on materials. Can you see the slide?
Yes.
Installation of deep foundation, and finally the quiz, right? And do you remember all these points that you studied? Let me ask a quick question if you remember, otherwise I will give you the answer. What's the difference between pile and pier? Oh, pier I am yet to cover. Okay, give me an example of a location in which you can use steel piles. Steel pile. Oh no, sorry, not steel pile, concrete pile. I think I stopped until concrete piles. Give an example situation wherein you can suggest engineer Tamdi, engineer Ahmad, engineer Tong, engineer Do, going to suggest the type of footing, type of pile. He decided that it should be deep foundation piles, right? And he has to order, he has to supply all the materials to the site. He has chosen concrete piles. In which situation he can, an example situation in which he can suggest for a concrete pile. There are many conditions and criteria involved. Just tell me one.
Load bearing capacity.
Load bearing capacity is what? No, it's all done. Oh no dear, it's like this. It's all done. He has found the bearing capacity of the soil. He has decided to go for deep foundation, right? With that, the bearing capacity story ends. Now comes the material, choosing material. Choosing material mostly depending on the site condition, right? Site condition, feasibility of the owner, feasibility of the project manager and the project itself. Site condition, availability of the material, country, region, stock, many other factors, right? External factors. Come on, give me one situation in which you can suggest for concrete pile. Okay, if not, just hold on, we will answer later. You think I have to get answer from you. Lastly, we did quizzes, right? I will go through the slide later. Quizzes. What are the results? Who? Tanzi Hao is here. Tanzi Hao. Tanzi Hao. Oh, he got marked and left the group, I think. Tanzi Hao. Not here. Ku Wei Jun is here. Ku Wei Jun. Hello.
Yes, miss.
Very good. Keep doing very well. Keep up
Thank
the
you,
work.
miss.
You stand second. And Khalif Muhammad Ali. Khalif Muhammad Ali. Muhammad Ali. You. Oh, is here or not? Okay, give him a big hand. That's all. Okay, see here, there are a team of people who is still proving 100%. I'll show in the next slide. See here, the 3 people are the champions for the last class, and overall class average, this is bothering me, 53% only. Although we are doing it on the same day, same class, you should get 100%. Okay, I know you need some revision, you need some go through again for answering. If you need, I will assign to you so that you can go through the lessons and then answer so that it is 100%. It's all for the purpose of learning. Okay, and then these people got some extra cards, wallpaper, sticker, ice cream, and so on. You see here that those 10 people, around 10 people I can display here, but 7 is here. Tanzi Hao, Ku Wei Zun, and June, Khalif Muhammad Ali, Maya, Kaum, Mohammad Munib Wang Ka Fei. Okay, good. Keep it up. Objectives of today's class. So we'll still continue with the deep foundation installation. There are some criteria and then selection, conditions, failures you need to understand. I will redo the concrete piles and go for steel and timber and so on. Okay. Formwork. Next, we will continue with today's class on formwork types. Under formwork, there are different headings. You need to know what are the construction methods used for building your formwork, constructing your formwork for the construction site, advantages and disadvantages of formwork, requirement of good formwork. Okay, this is most important. Okay, as engineer you should be knowing and well versed in this. What are the requirements? See, is still hazard. This problem, if you fail, it's equivalent to foundation. Each and every stage it has a hazard, right? If it is poorly designed, poorly planned, end up with hazards. So you have to take enough care. Quality of work should be there, planning should be there, and the construction, right? Requirement of good formwork. Lastly, quizzes. So today, if we have time, we run through. Otherwise, I post to you. I go to other slide, which is deep foundation. We left with 3 types, which is also important for you. One moment. Deep foundation. Okay. Deep foundation. Can you see the slide on deep foundation?
Yes, Miss.
Okay, thank you. One. I will start with the most important 3 types. So I have left last class because you had some other things to do. I could not continue. I just left concrete piles. I remember. Yeah, we finish all these things based on the material. We classify them into three materials. But you can come out with an innovative, strong materials, saying that this is your PhD research, master research, right? And these are the concrete piles. It will look like this, made out of concrete, precast concrete. Okay. Best concrete can be prepared, proper workmanship. Any defect can be repaired immediately. These are the advantages, right? There are advantages and disadvantages of going for concrete piles. Reinforcement remains in proper position and does not displace. The concrete only withstands loads after complete curing has taken place. So there is a sufficient time, unlike other precast piles, concrete piles, you need sufficient time for curing. More convenient when driven through wet conditions, right? And then it's also same holds good for most of the piles, steel or this, and except timber. Suitable when part of their length is to remain exposed. Not affected by other additional forces which act on the pile while adjacent piles are driven. Not affected by other additional forces which act on the piles while adjacent piles are driven. So concrete piles can take some vibration, can absorb some vibration. It cannot get brittle or make noise or slide or deflect due to external forces or other construction works going on at the site. So mainly the advantages, if you see, you because it is already precast, right? Care should be taken only at the site where it is manufactured, right? Like curing time, strength has to be properly checked, right? Properly prepare the report on the testing, and then conditions. I mean, other at site you can have. It will remain, the reinforcement remains in proper position because you constructed already. You only bringing it to the site. Because it is planned before, it is constructed before, you can have reinforcements already in place. You don't have to worry about while driving the reinforcement get displaced or concrete going not filled properly, completely, right? All these things will be avoided. And then the withstands loads after complete curing. So all other properties of the concretes are good enough for constructing or going for a sort of, where is it? Why I remove this one? 4 point. Oh, I'm here. Can you see the slide? Can you see the slide, please? Sorry, I suddenly jumped into this.
No.
Cannot?
No.
What happened? Very touchy nowadays, and the systems are very touchy. I think this one. Can you see now?
Yes.
Thank you. Right. Disadvantages, right? Now there are advantages owing to the property, owing to the mode of construction, and then next one is disadvantage. Immediately think of again about the material, heavy and difficult to transport, right? Sometimes you need to employ machineries, cranes, and then transport charges, logistics are involved. Lapping of additional length means, and this we already saw, right? At site you cannot customize or you cannot cut if it is an extra size that's supplied, but you need only half or 1/4 of the 3/4 of the pile is required. Customization at the site is not possible, or post construction, post modification is not possible. Heavier in section to withstand holding stress. Okay, the shocks of driving make the pile weaker, right? There are chances of brittle, right, during piling. If you forcefully do it, if you want to fasten the job, tend to brittle, right? So it cannot bear the shocks during driving. Heavy in section to withstand holding stress. Heavier in section to withstand. Yeah, you cannot pile up too much, right? Actually, piling is, it is driven one by one, right? It is driven one by one. You cannot make if it is a 100 meter feet, for example, if you are doing any of offshore work, 100 meter you have to drive. You cannot have 100 meter altogether, right? You need to have one. That's why the name is called pile. It's stacked one over another. So with the stocking, when you do the stocking of piles for construction of foundation, it cannot withhold the sectional load, because it is being driven. Care should be taken to position and hold it, transfer the load properly into the pile or subsequent pile during construction. Okay, right. Drilled piles. This is also we see already. You just dig a hole by using this shaft, pour the concrete, right? Pour the concrete and put the reinforcement, clean, put the reinforcement and then pour the concrete. Reinforcement comes first. This we all see already. Next type is
Sorry for interruption. I want to ask which condition we can use the concrete pile.
Number one, site condition. We can take with the supply. Start with the supply site condition. Supply sometimes they want cost effective, right? Cost effective. Precast is relatively less compared to steel. And strength wise also, concrete is suitable compared to timber. Okay, and then wherever it is very cold region, the marsh condition is it is on all through the year the climate is very cold, very very what do you call RH value is always high, then you can go for concrete, because there are chances of rusting, chances of problem in steel piles in colder regions, or in what do you call where it is always lying in the water conditions, river conditions, or across the bridge, right? It is supporting a bridge or it is supporting a culvert. Then you go, it's preferable, right? It's preferable if the design, if the stress is good enough for a concrete pile, you can go for it. But for deepmost, the highest piles should be built by steel. But proper monitoring and renovation should be there always. Okay. So mainly on the regions, mainly on the supply, stock material, and the stress. Okay. Any other question so far? You can see here
Miss,
different types. Yes.
how do they clean the shaft?
Shaft pile. What?
How do they clean it?
How to?
How do they clean the shaft before putting
Clean, right? Yeah, clean the
clean?
Clean by pumping water. Pour the water and suck out the. Use the centrifugal pump to lift the water after cleaning. Supply the water, right? Right. It's all by motor and pump. See the hose. The hose is put inside. Supply the water. It's clean. and then by centrifugal action they will remove the water. It's mainly because of this one. While digging, right, there is a chance of soils going inside, isn't it? That's why they have to clean it. And if it's worse if it is a loose soil. Okay, clear?
Okay. Thank you.
Yeah. And then we see here the conditions. NS also, see here, the length limitation. This also makes you choose RCC. That's why I said you cannot go for high strength piles like 100 meter and all. You have to go for steel pile. And the tonus also important. See, tonus is taking, I mean kilonewton, in newtons, kilonewton, 7,500 to 8,500 only, right? You can still use for high-rise buildings, and then cost is most cost effective for high-rise buildings. But if it is towers like TRX and Bosch, Khalifa, must go for steel. Okay. Let's move on to steel piles. It's interesting, and see how are the advantage and disadvantage. That's important. That makes you to choose the best suitable for the site. Okay. Useful where driving conditions are difficult. Driving conditions are difficult, and other type of piles are not suitable. Like if it is already a hot soil, a medium and type, medium and mixture of medium and hot type, then you reach the soil down, and driving is difficult. There are chances of brittle breaking for concrete and timber piles. So you choose steel pile, which is stable. The shape is not gone unless it is tend to bend, right? And there's chance of bending that we will see later how you have to protect. So you suggest for steel pile where it is hard, medium type soil, or mixture of hard and soft soil, or driving is difficult. Usually used for building and bridge foundations. Okay, building and bridge foundation. Buildings in what in high-rise, the hilly area, right? In hilly area terrain where there are more, some of the half of the strata will be rock, and then suddenly water, suddenly soil. There is a chance of changing, right? So you can go for steel pipes where it can break easily into the surface. The piles in the form of IUH, there are in pictures I will show you later. The cross section will be like IUH. These things are preferable. Don't ask me why you don't have any other. Again, it is following the code. Okay, it is all suggested by code. I have printed some of the codes here at the end of the slides. All of you please read through. Okay, although we are not using, but these informations are taken from textbook, which is taken from, which in turn referred by manuals and code books. And these code books, every country they have their own code books. Okay, what type of file, what type of section, what type of cross section, what is the maximum cross section, and the corresponding strength. Okay, all these things are written there. You need to follow them strictly, then you get the approval for pile driving. They will check through the manuals and the code books used. Every country they have their own. For Malaysia, CIDB, because in Malaysia they appointed CIDB as a representative for Ministry of Works. Sometimes some countries like India, it is directly to the Ministry of Works, Ministry of Public Works. Okay, they call Public Works. Those who are building constructions and so on, giving approval. Okay, so every country they have their own board which governs and which updates the code manuals and codes. Later I will show you in the website in CIDB. Let me finish this one. Usual length for this one is 15 meter to 16 meter, preferable. Steel pipes, 60 meter, it can go up to 60 meter. That is 40 meter, right? The one. But steel pipes based on the material, stoneware, cast iron, wrought iron, depending on the material, it can go up to 200. It depends on the construction again. Usual load 300 kilonewton to 1200 kilonewtons. Okay, and then a conical tip, right? A conical tip is used where the piles have to penetrate boulders and rocks. Okay, so to avoid any bending or cracking of the tip, they use the pile cap while driving. However, it needs to be treated before embedded in corrosive environment. That's important. The major problem of steel, using steel is a corrosion. To avoid corrosion, it should be treated. Apply corrosion resistant material so that, or any water impermeable material so that it is away from corrosion, because it's the base material, right? And the bottommost portion of the building on which all the loads are transferred all the time. So avoid corrosion, which will lead to failure of the pile. See here in the picture, nice picture. Can you see the H section, all of you? IRH. Huh? What section is it?
Yes.
IRH. Hmm? IRH.
I.
Okay, preferable I, because I like this one. What is it? Web size is very high. Sorry, flange and web. Based on the web and flange, you can define whether it is a H or other type what H or I type. Okay, capital I. And see here the cross. Sometimes it may be circle like this. Steel pipes. Already see there is a stamp on it. It looks like a rusted pile. So care should be taken to avoid not using in most moisturized moisture conditions or RH. I mean, always all through the year, like UK, all through the year it is cold, even negative, right? Going to negative. So try to use precast with by choosing proper strength and grade. By increasing the grade, you can achieve the strength. I think you would have studied in other material RCC lessons how you can improve the grade of the concrete and the corresponding strength. So choose the proper concrete so that you can replace with steel at these places, moist conditions, swampy area, and so on. See here another pile, hitch pile. They call this as hitch pile. Inserting hitch pile after pre-boring. So pre-boring done, cleaning done, remove everything, and the pile is driven with the proper lining material, corrosive material at the bottom is driven. Hydraulic hammer. So it's act depending on based on the hydraulic jack principles. Where is it? You cannot see here. Okay, anyway, this portion and this whole portion, the pile is at the bottom. This whole portion is called a hammer, and there is a leverage for the hammer to raise and up for blowing. And then side welding to connect hitch pile. Side welding. So one pile is driven, another pile is coming in. They are welding it to connect it. Okay, they are connected by welding. So pile is already one or another, right? That's why it's called pile foundation. The pipes or the sections are put one or another into the ground with the proper joints. Joints are very important. Care should be taken to firm it. Allow some time. If it is a concrete, allow some time for curing. And then if it is steel, proper welding, thawing. In welding, we call this as a freezing and thawing, right? Freezing and thawing, the time has to be properly planned and avoided so that it has settled with it has reached the strength. That's important. The time retaining time is for reaching the required strength. So they are doing the welding for the second pile to be driven together with the first pile. It's driven for 12 meter. Okay. Advantage and disadvantage of steel piles. Very good. Make it specific terms like this. Can you all read the slide? I mean, see the slide clearly? The letters very small. You can read?
Yes. Yes.
Okay. Advantages. Come on, let's read that. Advantages. Less hassle, because brittleness is not going to brittle or break. So less hassle in handling during installation and easy to achieve cutoff levels. Okay. It means easy to achieve cutoff levels. Mainly because you can nicely cut it wherever you need to customize it. The remaining portion need not be protruding out of the ground. You can easily remove it. You can easily customize it by proper cutting equipments. Okay, at the side. It is very rare, but we choose the pile where it is occupying the whole length or as per the design. High driving force may be used for fast installation. Yeah, you can speed up the process because it's steel, but care should be taken. It is not banned. It is not overheated. There is a heat produced, because you're hammering, you're producing heat, right? So care should be taken. It should not bend. It should not. The temperature is not going up, right? Good to penetrate hard strata. load carrying capacity is high. Okay, steel pile can bear high load, so advisable for if it is a soft soil, you need to replace with the high strength, then you use piles to achieve high strength. It can easily penetrate through hard strata, also penetrate through hard strata, unlike other piles like concrete and timber. It can easily penetrate through hard strata. Disadvantages, right? Always think about the material and answer all the properties, then you are having the advantages. Relatively expensive, right? Steel material, it's making manufactured, and the ore has to be taken and it is manufactured, right? Not the affordable material like cement, sand, gravel, right, which is used for concrete, or timber, wood. By growing trees you can have more trees, you can have wooden materials to prepare to manufacture your, if you are running a wooden or timber pile construction, pile manufacturing company, you grow a plantation, you have already some material being supplied for your company, right? But still you have to have, depend on the ore, right? Depend on the if it is, if you are manufacturing, you have to depend on the ore supplies, and then the hence it is very expensive. Okay, because of the raw material it is expensive. And then noise pollution during installation. Disadvantage is noise pollution, because steel, right, metals always produce noise, right? Whereas the concrete and timber have less noise, only the hammer sound. The hammer is already steel, stuck on to the steel will be very vibrating or supersonic sound. On the other hand, the hammer which is striking a concrete or timber will be absorbed a bit, and the sound is very less. Pollution is very less. Corrosion problem. Bending in piles while driving. Yeah, that's why I said when the temperature, see, it is not the temperature that you feel on the ground. When it is being hammered, it produces a very high temperature. Okay, chances of bending at the hammer point itself, there it has happened so far in some of the companies, they complain. So care should be taken. If you want to speed up, it will produce lot of heat energy, and the heat energy change to bending, turn to fail the pile or bend the pile. So care should be taken to avoid bending during installation. Any question on steel pile?
No, miss.
Okay, timber piles. Limited load bearing capacity. That's where we start with a low timber. Timber is most commonly used for your information. Most of the people they are using, we will see how they are using and what are the limitation. It's mainly because of residential buildings. More residential buildings are built using these piles. Load bearing capacity is low because they are constructing on a hard rock soil, right? Hard rock soil can have just a timber. Using timber you can build your construction, build your house. And then what, shorter depths, right? You can adapt shorter depths for buildings like single story or double story bungalow type. And length of timber piles depends on the type of trees used to harvest the piles. You should know the type of trees, whether it is a balsa wood, it is from bamboo wood, or plywood, right? Hard plywood also nowadays they are using. But you have to have knowledge on the strength, bending strength, and then composite strength, all types of strength. The manufacturer should have supplied you the table, the testing table, all the properties table of the material. You should go through and then choose it accordingly. Common length will be 12 meter. It's hardly 12 meter. When other piles can go up to 40, 60, it can go only up to 12 meters. It is susceptible to termites, yeah, attacked by termites and fungal microorganisms, some insects, right? Marine organisms are not rot within zone exposed to seasonal changes. So this is the termite problem. Termite problem or growth of fungal, like what do you call, honeycomb type of insects, right? Insects living there, breeding there. And then even though it's cheaper, but it has low capacity and cannot take hard driving. Okay, even though it is low capacity, right? And because it's having low capacity, it's not, even though because cheaper, it's cheaper, but cannot have take up the good load, and have to choose only for less load bearing strata. Okay, I see the pictures, see how it is. These are the square piles and these are the piles again, and the pile tip, the pile tip is like this. This is anchored to the ground, pile tip. And see the construction in Malaysia, in Sarawak, I think Sarawak, most of the coastal regions, they have coastal region and tropical regions. Tropical region, they will use this type where there is watery and there is swampy area, right? Loose soil, more loose soil. You can go for this type of foundation. But again, the problem of termite, problem of swelling, wrapping, right? All these things has to be attended then and there. Proper monitoring should be there, but affordable for poor people or short living, right? So and movable buildings. The people who are living in water, they build the construction. You might have seen in Australia and then what? Papua Guinea, right? The island nearby Australia, Papua Guinea. Most of the houses are movable houses. They built in sea, or they built in seashore area, rivers, so that they can move anywhere. If there is a sudden heavy downpour, storm, windy storm, they can move anywhere they want. Okay, so in these conditions, movable houses can be built using these type of foundations. Advantages and disadvantages of pile foundation. All of you know that this is less expensive, affordable. Timber available as timber can be used after suitable treatment. Yeah, care should be taken to avoid honeycombs and then termites, fungal attack. Can be made longer in lengths by joining the individual pieces easily. Yeah, easily can be connected, right? Proper bonding can be created by screwing, by hooks, and by proper proper brackets and proper nailing arrangements. We can have connections quickly done, unlike you wait for welding and freezing, right? Reaching the strength, it is quickly done. Cutting of these piles are easy. Yeah, wood is easy to cut compared to stones and concrete. Can be driven easily with lighter machinery. So machineries involved, facilities you have to provide will be less, and this can be made in situ. You can even prepare your own sizes of piles at the site itself. You don't have to wait for the supplies, or you don't have to order and take time for that. Okay. You can see there are many videos and pictures you can see related to this. Let me show some of the pictures here. The rest and the more knowledge you have to gather by self-study. Okay, because we cannot cover everything within this duration, right? There are interesting videos showing how the timber house is constructed, how the how the timber piles are used, right? What are the conditions they follow. And there is another video I will post if I come across. They classify between different types and different materials. That is so interesting. Okay, the piles deteriorate because instead of reading and seeing, if you watch through the video, the actual operation of the work, you understand even better. Okay, that's why I ask you to go through video. The piles deteriorate by action of water and insects. Yeah, so because of termite action, susceptible for any termites, attract any microorganisms, easy for water interruption, causing holes, causing honeycombs, causing failure of the pile itself. Lesser load bearing capacity, you cannot use it for high bearing capacities. A number of small individual units required to construct long piles. You cannot, there is a length limit. I'm sorry, I don't have right now in my hand, but there is a length limit according to the code books you can refer, and according to the soil condition, you cannot have a longer piles. You have to have shorter piles. By that, number of piles used will be more. You can have a comparative statement based on this, whether the number of piles will be costing more than the steel pile or concrete, then you suggest for concrete piles. This entails a lot of joining work, and as such, cost becomes high in constructing the piles. Okay, so you must always have a analysis in choosing the pile based on the condition, based on the supply, based on the climate, based on the company project. Okay. Lastly, composite piles. Yeah, mainly we classify them into concrete, steel, and timber. You can have also combination of all these three, or extra material like plastics also can be used. We will see how it is. A pile in which upper and lower portions consist of different types of piles. Okay. Composite pile is a pile made of steel and concrete members that are fastened together end to end to form a single pile. You see here, this is the concrete shell or a box, right? A concrete box is prepared and an I section is inserted, or a I section, let it be I section, it seems I section. An I section is inserted into the pile as a reinforcement. Instead of reinforcement, they have these steel piles itself as a filling material or load-bearing material, load-bearing member for the pile. And it is a combination of different materials of different shapes, materials such as pipe and H-beams and or steel and concrete. So it's here another one. I'll show the picture bigger. One moment. Okay, can you see the picture here clearly?
Yes.
One moment, I put it fuller, then you can understand clearly. Okay. See how the composite pile is made. This is concrete, right? This is concrete. This is concrete. On top, inside we have the steel. Then they go for another form, pour the concrete, and then go ahead. So instead of a reinforcement, they use the steel piles itself as a reinforcement material for the concrete. For the maybe this is the abutment. See here, this is a river. Whenever there's a structure constructed across the river, it is called abutment. A-B-U-T, abutment. I'm sorry, say culvert. It's called as culvert. One of the super drainage structures. So this drainage structure, they are constructing the N walls. These N walls, see here and here. These are the N walls. N walls are called as abutments. These abutments are constructed using this type of composite pile, which has concrete and also the steel. So it will continue until the height of the bridge, and then the slab is constructed over this. May see the closer, see the interval. It's mainly because this is a floodplain already. This is a river or a small stream, floodplain already. So you need to have a proper anchorage of the soil. Soil erosion is quite common. So you need to anchor it properly into the ground. That's why they go for composite, not just a single material, either steel or timber or concrete. They go for a composite material like this. So the middle piles can be just a concrete or a steel pile, while the end piles, which is going to take the load, transfer the load, the support being made very strong using composite piles. Type of pile foundation. Adoy, what is it? Cannot hear the system. You can hear my voice? Can you hear my voice?
Yes.
Yeah, we can hear you.
Message coming, can audio system.
But cannot see the
107. What happened to 7 more people? Some information I given in the beginning. Let me give once again. All of you complete your theme presentation topic. I will post the assignment question by next week, and also your schedule of presentation. I will post another link for you to upload your slides. Okay, I need your theme presentation slides. There is no strict procedure for that. It's only guideline for your presentation. Just use 5 slides enough, because 3 minutes only. It's up to you. You can use Excel sheet, image. Just keep one image and keep on talking. Also okay, but highlight very clearly, very specifically what you understood from that particular topic, the theme or project or material. Okay, that's important. How much you understood and how you can reproduce. That's all. Okay. The rubrics also I put together. Better I put the rubrics. I post the rubrics in the same slide so that you will know the rubrics. Then based on that you prepare and present it. Okay.
Miss. When is the presentation start now?
Week 12.
Week 12. And how about I saw the course outline. There's an assignment for about 40%. That one is when?
No. Is it 40%? I changed already. You see the current one? Maybe the very beginning I posted 40%. After 4th week they updated. It's changed to 20, I think. 20% assignment.
Oh, okay.
That
that one-
assignment I post on week 10.
Okay.
And
That
the
one is
written,
individual also or group assignment?
all are individual. All assignments and testings are individual.
Okay, thank you.
You can post after 2 weeks. Always assignments are given 2 weeks time. So week 10 I post, week 12 you submit. Okay. In between you have to post for the slide. Remember, don't forget. I will give you the rubrics together with that so that you understand before you come for presentation. How you have to be prepared for your presentation. Okay. Where is my slide? Composite piles. Can you see composite piles? Can you see now?
Yes.
Okay, thank you. So this is how you have to be careful in site specific and understand the condition of your site. Remember everything before you decide, and then advise your subordinates at the site. Types of pile chosen depends on the following factors. Now the factors also there. You see here. Just now we were talking about the comparison. You can relate to this one. What type of pile is readily available? That's why the supplies. Sometimes the contractor supply all the concrete pile. Sometimes this type of foolish action will be there. You need to face it sometimes. So see that whether the strength is okay, whether you can increase the number of piles, the spacing and so on, manage with it. Location and type of structure, magnitude of loading, that's most important. Magnitude of loading, when I say here, come on quickly, I don't want to ask many questions because I cannot cover some of the syllabus, but please tell me, when I say magnitude of the load, can you tell me quickly what are the types of load? Dead load, then come on.
Live load.
Live load, then
Wind load.
Dead load, dead load.
Wind load.
wind load. Wind load and skyscraper, you must go more than even 3 floors. They started doing it because of the changing scenario, climate change and so on. Above 2 floors, you should go for analysis for wind using StatPro or Revit or any other software. Okay, wind load. Again, you follow the code book. In the code book, the type 1, 2, 3 methods are there. You need to adapt exactly the required type of wind there. And then, because the lateral movement is not only downward, the force is acting laterally, wind load. Okay, next, last one, earthquake. 4 types. Remember these 4 types. Okay, assuming that in all your designs you have these 4 types of loading: dead load, wind load, dead load, live load, wind load, earthquake load. Okay, all these 4 you need to analyze for any high-rise building for sure. In doing this, you should know the quantity, right? The quantity of the loading, quantity of the bearing capacity of the soil. Then you choose ground condition, soil type, the bearing capacity, and then type of structure here. Here location and type of structure. The location is related to climate, which location they are. Always in water or environment and climate you can put together. The environment maybe the structure is in water, the structure is a submarine structure. The structure is floating, structure is on the ground, structure is on the hill, and so on. Then cost, right? Soil type is important. Soil strata also important. Oh, I forgot today. Remind me, I will bring the borehole before I finish at least next class, because we go to superstructure, you forget this. Borehole, how the borehole structure will look like, borehole testing, I will bring next class. Cost of the pile also important. Sometimes the manager, the owner wants to save money, so you have to go for cost effective materials. Durability, at the same time you should have durability of the in all structures, right? Irrespective of what type of all these things, type or condition or structure, you should advise for durable material. That's it. Type of pile construction. So it is something similar to what we discussed so far about the types and the methods. Just a recap of some more information on how you do the construction. There are 2 types, displacement and non-displacement. Displacement piles. You see here, falling white, right? Falling white. The crane is not shown here, but just understand the illustration only at this point. it caused the soil to be displaced. Okay, soil to be displaced radially as well as vertically as the pile shaft is driven or jacked into the ground. So remove the soil, and then by driving it is removing the soil laterally or radially, sideway to be driven into the soil. The second one is here, it is being driven and is already driven. Okay, the pile is already driven. Non-displacement pile. Here you don't have to mainly this type mainly for the steel and composite piles will follow this one. It looks like a composite pile because it have a shaft here and then the pile is driven here. So the pile is already driven and the shaft is here. Okay, shaft is here. This is all moving the soil, and here you no need to move out. Just make a hole by the driller, by augers or any heavy instrument, and then pour the concrete. Not immediately pour the concrete. Do the cleaning, place the reinforcement in position, and then pour the concrete. Okay, this is called non-displacement method. How I think you saw the video clearly, right? Remember the video you saw how hammering is done for driving the piles inside. Remember the video I showed last class, right?
Yes.
Okay, just recall the video. This component parts I'm explaining here. During pile driving, the hammer will have this structure like this. This is the position, and this is the hammer, hold by a cap like this. This is packing. It acts like a cushion for the material to move, to have a movement inside. And this one is a support for this hammer. And this hammer is driven by a pump, motor and a pump. Location you have motor and the pump. You switch on the motor, it will start driving the hammer inside. Sorry, start blowing. And this is the pile. Okay, this is the pile. So hammering action is done on the pile to drive into the hole. Okay, drive into the hole. Precast concrete section. This is the precast concrete section. Okay, precast concrete section is being driven into the hole. I just broadened the view, that's why you have an enlarged view of this thing. So you see here layer by layer, pile 1, pile 2, pile 3, one after another it's being driven into the ground. So this is being this will be mounted onto the crane, carried by the crane, which is on any vehicles, right? The crane is located on a vehicle, brought to the side, blown to drive in the piles inside the ground. You see here the pictures in real life. You can see the pictures like this. Smaller the picture, resolution is not good. Okay, see here the hammer is a vehicle carrying the crane, and the crane is holding the hammer, and then there's driving inside. The picture is not so clear in this, but here you can see the hammer arrangement, right? And this being pulled up and down inside. And this is the precast concrete. Concrete is placed one after another and being drilled inside. Okay. Piers. Next type of deep foundation is called piers. So for any question on the deep foundation, which is using what do you call piles? Any questions so far? Only 107. Still 7 more people. Please check your friends whether all are here. Check in the class team whether all your friends are here. Advise them attend classes without fail. Otherwise they cannot renew their visa, right? They have a problem of barring, right? Advise your friends. Check then and there whether they are here, whether they need any help. You do teamwork, although you are not you are not connected personally. Just make a network, talk to yourself, get help from each other at times of need. Okay, especially notes, sharing notes, even studies with difficulty, you do group study, you can understand even better. Okay, because as theory, one can present to other to listen and memorize. You have to memorize some of the theoretical point of view, right? Although we don't have examination, but some of the points you have to keep in mind. You cannot go and refer always through the manuals and textbook. Some points should be in your mind. Okay, let me continue with this. Few more only. Okay, and then we move on to types of form works. So for piles, right now piers, and there are videos, all interesting videos, and you can watch through what are the variations between piles, piers, and caissons. What are the piers? Piers are foundation for carrying a heavy structural load, which is constructed in situ in a deep excavation. It is a vertical bridge support. Okay, piers are just pillars, and it's called as a pillars. There is a difference between piers and pillars even, but for your understanding, it looks like a pillar. Okay, it looks like a pillar. You see here the arrangement. 3 girder deck. This is a slab, and these are the beams. Okay, slab, beam. These are the beams. We'll take the laser pointer. This is the slab deck, and this is the beam. Okay, and these are the piers, tapped with infill or curtain wall between columns. Okay, this is built with curtain wall in between, and these are the piers. And then here another type called pier type with 2 columns for 4 girders. 2 columns for 4 girders. Girder beam. The girder beam is a rectangular girder beam. Girder beam is the beam. Main, these 10 beams are called main beam and secondary beams. Sometimes secondary beams will be constructed, but you cannot see here in this view. So these beams are supported by this foundation, right? And the slab and the beam together is supported by this foundation type of piers. Another example, individual spread footing truncated pyramid form. Okay, the pyramid form footing is not a slab, but a pyramid form. A slanting slope is given so that the load is gradually distributed and uniformly distributed throughout the footing. Okay, the footing is holding the pier on which the structure will be loaded. Examples, all piers. Piers, continuing in the piers. Maybe this is broader than this. See, when you go down, it will be slightly increasing in diameter. As you go down, you can see increasing in diameter, so that they distribute the load smoothly into the ground. So these types of foundations are called pier foundation. It is not concrete, it is not steel. Maybe a small stream, and it is not often affected by flood or not often affected by any type of climate changes. Okay, then you can go for this. If there is a overtopping, chances of overtopping often is already full, the river is already full, maybe because of the cost effective, right, the cost effective nature, they would have constructed these types of piers. Caissons. Well type. Caisson, when I say it's a well type, well, hollow box, a prefabricated hollow box or cylinder. Sunk it. Okay, I wanted to ask one question. You see here circular. Okay, these piers constructed circular. I don't ask this question now. Okay, I ask later. Caissons. A prefab is a hollow or box type or cylinder type. Okay, sunk into the ground to some desired depth and then filled with concrete, thus forming a foundation. Okay, they are all the hollow type, like a shaft pile. They dig the outer layer first, desired depth, and then fill with concrete with the reinforcement. Most often used in the construction of, whenever I say concrete, you take it as RCC, reinforced concrete. Most often used in the construction of bridge, piers, and other structures that require foundation beneath the river and other bodies of water. Okay, wherever the structure is sitting on the water, you can go for caisson type. Why? Anybody? Can you guess why it has to be caisson type? If there is any damage by because the piers are sitting on the water, always sway, chances of swaying, chances of erosion, right? All these things will affect only the outer material first, right? So it will indicate the failure by affecting the outer material. Once it is indicated, you can do some renovation or strengthening foundation. There are methods of grouting. You can go for grouting and so on, right? That's why they have two materials preferable in river structures in water, river, marsh condition, swampy condition, to go for 2 layers. So it will affect the first layer, and the core part is still transferring the load to the underground. Okay. And this is because can be floated in job site and sunk into the place. Yeah, that is not the only purpose, but the main thing is this indication of the failure. Okay. What is caissons? Similar in form to pile foundation, but installed using different way used when soil is adequate. Bearing strength is found below the surface layers of weak materials such as fill or peat. Okay, there are fill material, and then you have the surface hard foundation only beneath. So you don't have to have a very hard foundation at the point where it is very hard already. It's already hard. Only soft soil has to be supported by strong material. So you can save material by advising caisson in the place of steel foundation or any other type of pile foundation. Okay, you can save time. Sorry, save material to advise properly where it is a combination of loose and hard soil. The form of deep foundation, which if it is a throughout soft soil, you must go for pile foundation, right? A form of deep foundation which are constructed above ground level, then sunk to the required level by excavating, dredging material from within the caisson. So it's a type of foundation which are constructed above ground level. Sometimes there is a necessity to go for foundation continue to the top, because my structure is flyover, maybe a flyover. Sometimes it may be a crossing. Your structure is below. There is some facility on the top, right? You need to support that as well. So all these types of cross drainage and super passage will be constructed using these types of caissons. Easy and effective, cost effective method of design. Examples you can see here. Okay, there are chances when I talk about this one, these caissons, there are a number of accidents due to these caissons type of piles. Why have you come across the recent news? There is a recent news, 2 days before they build the caisson, finish. I mean, the bore is done, right? The outer layer is done, the skeleton is done. The next day they are supposed to go for piling. It is open, the well is open. There are chances of people, if it is not protected properly, chances of people, passers by, animals fall into the pile. So care should be taken. If you are a supervisor of the site, an engineer at the site, you should be careful. Hazardness is more due to this caisson type of piles, where you not only caisson type, wherever you dig and leave it, there is a chance. Before you start your piling, you should check, right? You should check and then go for piling. Recently, 2 days back, 2 days back, one old man fell into the well. It is not a caisson foundation, but it's a well. It was dug. It is left like that. It was not. It's abandoned, maybe abandoned one. One old man fell into the well. There were 30 people employed to take him out. He was suffering. First of all, he was suffering for help. He was shouting for about some hours or two, and then people came in. They helped him. You know how many people employed? 30 people employed for about 30 minutes. They say 30 minutes, I think. 30 minutes to save him, to bring him up to the ground. The depth is just 3 meters, for your information. Depth is just 3 meters. 3 meters. Why I'm saying this example? See, today's technology, although we are in a developed world, they spend about 30 minutes. 30 people have been employed to recover one man who fell into the ground. This is how the equipments and the machineries we have right now. Because a human being, right? If it is a steel or iron, they can use a magnet to bring it up, right? So it's a human being. To safeguard people like this is not only in wells, in mines. Many people in mines. I myself got some consultancy projects, but I couldn't go for that. consultancy project to safeguard people who are suffering in mines, same problem in mines. So we are not developed in terms of instrumentation to shorten the time of saving, shorten the time of accidents, safeguard people at times of emergencies. Okay, so these are the area you can work on if you are applied as an engineer, and you can also look into this part. Please take care. We are seeing another type of wells. What is this? Hose. See the parts. Plastic hose for supplying of fresh air. People working at very deep, right? As you go down, what will happen? Pressure will be less or more? Yeah, tell me. Pressure will be more or less? Yeah, pressure.
Less.
No air, huh? No air for him to breathe. So you need to supply air. Concrete rig to protect the sides of caissons from collapsing. Concrete rigs, like kind of a bracings are given to support the casing. And then electrical cable, lamp, and water pump. See here, all these facilities to be provided for doing the concreting, if it is a concreting. Okay, and then this side, hose for pumping up of groundwater. This is a well, the real well they are constructing. And so after construction, they found that there is a water coming out. They have to remove. If it is less water, if it is from a continuous supply of water, continuous aquifer, like confined aquifer we call, then you should avoid this place. You should really close it back, right? If it is a small layer of water or intermittent water, small parcel of water, you can pump out and continue your digging. It's all given by borehole test. The strata will be studied. Based on that, you can go for advice for further construction. Hang dug casing, working in sloped site. Hand driven. This is, where is it? The picture is seen here. Dug well, it's kind of a dug well is constructed. Just they go for 10 meter or small number of wells, right? Small, deeper lengths, deeper depths. Then you can use for this type of hand dug. It is not machineries employed. Hand dug, but the machineries, what else are doing? Maybe clearing the site, like they're using this one for clearing the site. So hand dug wells are also advisable at places where it is not necessary for a deeper and heavy load is coming in. You see here, this is also here. Some pictures showing the hand dug wells. Why often I want to remove the permission, but it goes off. Sorry. Okay, I think few more slides only. Okay. Another type, the bore caisson type one, the well type. Caisson means wells. The well type will be like this type, 1,000 tons reinforced concrete caissons for Ro-Ro terminal in Ireland. An example wells, example caissons constructed for constructed in Ireland is showing. And this is another type, steel piles, caissons, the caissons which is stuck inside, and then the concrete is poured or steel pile is inserted. Depends on the requirement. You see here all these construction, water construction using the piers, using piers. Okay. And the piers also acting as a foundation for intake structures. You see,
Excuse me,
yes.
I cannot see the slides.
Oh, thank you for saying this. This one I showed just now. This one we were here, right? Dug wells, dug well type, a small depth foundations using caissons. Caissons means a well type, and this is box type caissons used for road terminals in Ireland. Example 1. Another type is here, steel shell, steel type of caissons are used. And this one is the concrete caissons which is constructed for intake structure. Might be on top, it may be a intake structure. Intake structure means a structure which is used to store water drawn from this river. So it is supporting the intake structure above. So it may be extended to some height up to which the water is taken. So any other? So these are the types of piers. Types of caisson foundations or well foundation. Well type, hollow, and inside it is concrete support or any pile is driven. I stop here. Any question you can ask me for deep foundation. If not, I move on to next topic on form work. 109. 5 people missing. Every day 4 or 5 missing. I don't know why I can't get 100%. 1 week before 100%. Okay. Any questions so far?
Miss, for the caisson foundation, it is constructed on the ground level, right?
It can preferable if there is an extension to the up above the ground level, like for the super passage, supporting super passage, flyover, intake structures, you can go for caisson, which is cost effective.
Oh, all right.
You don't have to construct a big pile on the ground, right? Beneath the surface, it is going to be deep foundation like piles. Okay, the caissons might be supported by. Otherwise, throughout the section, it may be caisson depending on the height. Sometimes, like flyover, if I talk about highway flyovers, 3-4 tracks it is carrying and supporting, then it may be piles continued by caissons on the ground possible.
Oh, okay. Thank you, Miss.
And in this case, you cannot use steel piles because of rusting, right? So preferable concrete piles on top, caissons possible. And then what else? Okay. Any other question? I close this and open the formula. Why is not closing? It takes longer. Doesn't matter. Close it. Form work. Gee, you already 6:11. Where is my slide? Close fully. Okay. Can you see the slide? One moment. It takes you so many slides. You'll have a problem. Save. Desktop. Not a set. Okay. Okay. Any questions so far? No. You have to read more. I can only give the salient points of the construction, but full coverage, please have a practice of going through the course. Engineers, you want to become a successful engineer, example engineers, if you want, there are very good people. I don't right now remember those people. If you want to become eminent engineers, you keep reading. Those manuals will be in your tip of hands. All the codes, norms should be in your hand. For this, you have to read every day. Some code books are freely available. Some of the things I have uploaded already in the note section. Some you need to buy or you can rent it. Okay, if you want, you can ask us to rent it or borrow from. We can provide you. We can purchase and provide you in the library. If you are using for your project, you want to learn more on that, you can suggest to us. Okay. You can see the slide.
Yes, miss.
Formwork.
Yes.
You are seeing the slide formwork, right?
Yes, miss, we can see the slide.
Okay, thank you. You tell me 10 minutes before I have to start that one. 14 only. Okay, covered by third. We jump to third. Already I told you this coursework, outcome. You have to classify the temporary structures. You need to classify and understand the type of formwork and scaffolding. Let's see what are they. I jump to today's class. Right. Your formwork will look like this. Okay. Before I go into explain, you should know who is this gentleman formwork. Okay. That's why I brought the picture now. The formwork will look like this. Formwork. The other names are shutters. Otherwise, I can call this as a supporting material. Shutters, scaffolding also there. There are standing components are called scaffolding, which is supporting. So formwork, shutters. There is another word I forgot. Okay, formwork, shutters, supporting structures, all are called as formwork. Okay, for example, here a beam. This is the supporting structure for the beam. This is for the column. Okay, and these elements are useful for constructing your building elements like beams, columns, slabs, staircase, see here staircase, and so on. Okay, these elements are helping you to support the structure. Okay, support the structure, support the structure you're going to construct. So example supporting structures, that they are temporary. Okay, they are not going to take any load. They are temporary. They are only taking the load during construction. Okay, they are temporary. They are supporting. They are acting like a container for your structural elements like beams, columns, staircase, slabs. Okay, slabs here it's wall. Wall is being constructed using this support structures, which is forms. Formwork. This is the formwork for the wall. Formwork for the roof. Formwork. These are the scaffolding. The spacing is most important. Always when I was working in cell, the engineer will come and check this spacing and the support at the bottom. Right, you have to properly firm it, anchor it to the bottom surface with the proper anchorage and the depth. Otherwise your concrete will collapse. So you need to check the scaffolding, spacing and support at the bottom before you go for concreting. So you understand your hero today, what you're going to learn. These are the structure, and today you will see how what are the types, what are the materials, what are the advantage, disadvantage, how it is constructed, and then use and throw. This is use and throw type. It is not going to be in the structure. Later it is forgotten. This material is obsolete. How? Okay. To mark the component, before I go teach on the theory, you should know what are the component parts of a formwork. Okay. It's time for the component parts are this one. You see here, plank. This is a plank. It will if it is going to you're going to construct a slab or a floor, then start with a plank. You will have a plank like this, and the planks are supported by crossbars, which is scantling. Some the names are a bit varying from region to region, but this picture is very good illustration. That's why I brought here. One of the form structure is shown here, which is used for maybe they are going to construct the slab. So for slab and the column, these are the shown. These are the structure. It has a component parts like a deck or a plank, and a scantling, and the beam. The runner, main runner is for supporting the whole structure, and this structure and this beam is supported by the steel scaffolding. These are the screws. These are the screws. Right, these are the screws which will support the beam and to the column, and these are the bracings. These the cross ones, and the cross diagonal and horizontal ones are called as bracings. The diagonal and you can see can you see the slide?
Yes, miss.
This horizontal and these cross things which holds the columns are called bracings. And these pipes are not continuous. Sometimes they are one by one. So a proper pin arrangement or a tie should be there to connect one after another. A base screw jack. Also all together it is supported at the bottom by a screw jack or a plate, sill plate. They call this is a sill plate, which is anchoring to the ground, right? This is one arrangement for the slab. For column it will be looking like this. So it's a temporary structure which is used for construction of concrete. We will see how they are done. So this temporary structure or hollow box or well, how it is constructed. Here this is for column. A column box will be constructed like this for constructing a column, and the formwork will have component parts like this. This is the mold. It can also be called a mold, a box, or a container wherein the concrete is poured. Concrete is made or manufactured or prepared, okay, in situ. Okay, what are the parts? This one is the mold. The whole structure is called mold, and this is the locking pin. They use the very interesting. If you see the video, I will show you later. Locking pin, how this is assembled, I will show you later. So first of all, start from here. They put the sill plate, and then the wooden planks are arranged. These wooden planks are supported by these bracings. These bracings are connectors, and these connectors are end with locking pins. Okay, there's overlapping and locking pins are there, so that you can keep the planks in position. And this is for the shear wall. This is a mold used for constructing a shear wall. Slender wall or just a wide sliding only, not taking any other type of load. Okay, a wall constructed, concrete wall can be constructed by using this scaffolding or using this formwork. It's called shear wall. How is it? What are the components here? Again, this is called a board, and this is the board. These are the boards, right? And these are the scanting beam which is supporting this board or the planks. These planks are supported by these scanting beams, right? And these cross scanting beams, different sizes are there, but here they use the same size. And then what? The pin. You see the pin, how they anchor it or latch it. You see how they latch it? There is a plate connecting between these two, and then there is a hole to latch it. Okay, you release the pin, you can take out the latch. So many formwork. Okay, what is a formwork? Is a mold or box into which wet concrete can be poured and compacted so that it will flow and finally set to the inner profile of the box or mold. Okay, it is a mold or box which can be used for pouring concrete, and this has to be there until the concrete is set. Okay, don't remove this next day. What is the time duration for curing for concretes? M15, 1:2 grade. Any idea? Those who studied RCC before, how many days you need curing? I said you have to leave the formwork for curing until it is done, right? Until it is set. Should not remove before. How many days?
14.
2 weeks, right? 2 weeks.
Yes.
If it is a slab, you have to leave for 1 month. Okay. If it is a slab, you have to leave for a month with curing. Okay. Right. Depends on, and again you have to refer from these code books. Referring to a code book, don't worry if you are posted in Netherlands, Switzerland, Japan, you refer to the code book. There is slight variation depending on the climate. Okay, CIS even oh, I didn't use. Okay, we go through this one now. With this I can stop and we can go for QZs. You see here, this is the code available for all the formwork scaffolding types in Malaysia. I've taken from Malaysia. India also they have their own IS code. China they have their own IS code. Internationally also you can follow by going through the ISO organization website. You can take the code book. And we go to this one. CIDB has come out with construction industry standards. The CI is referring to construction industry standards. So they have all the information, tools, I mean the criteria, the sizes, limitations, strength limitations, depending on the soil type, depending on the location, they are given for Malaysia. Let us go through this website better. I have to show you so that you can spend time on this to read. If you go to this website, you can see interesting websites, I mean code books available for you to read. I cannot teach you the code book, you only read the data and adapt it. No need to teach. It's like tables for you, tables and manuals. Open this one. Let me share the slide. You need to follow. I didn't show this one. Maybe we have to post our quizzes today. I need to complete at least some portion. Come on, can you see the slide? I mean the website? CIDB
Yes, miss.
website? Oh, very good. Under the standards, the publications under standards, if you go through the standards, information under standards, you see here there are standards. Low cost construction industry standards 1998 they developed for low cost housing, 1 or 2 levels only. Take this book, read before you go for construction. Low cost construction flats, and then housing other than flats, and then low cost, medium low cost, quality assurance for fabricated timber truss system. Both versions sometimes available, sometimes in English only. Quality system for building construction. Let me go to our own form work. You read later. Safety also there. See, and working at night. What are the conditions? I saw an interesting one. I see working at night. What are the guidelines? Can you see can you read it? Guidelines for working at night. Can you read?
Yes.
Okay. I go to our own stuff. Where is it? It's somewhere here only. Yani, safe use of false work. This one. Occupation washer. I think this is the one. There are 2 types I found. Manufacturer certification and safe formwork and construction. Okay, these 2 you can use it. Scaffolding in construction, right? All the columns that is used to support the formwork, and then the formwork. False work or temporary structure and the formwork in construction. All the rules and regulations, spacing, and everything is given. Materials are given. So you can refer from this before you go for construction. Okay, I stop this one and go to slide. Okay. You can see the slide, right? You can see the slide?
Yes, miss.
Yes, miss.
Purpose of formwork. Okay. Let's understand what is the purpose of formwork. Use of formwork. To contain freshly placed and compacted concrete until it has gained enough strength to be self-supporting. So you are preparing, it's like a boiling, what is that? You are you make idli in India, and you make what? I've forgotten your food, Chinese food. Just boil it and steam it and take it out, something like that. So you need to wait until it is settled. So you pour the concrete inside the mold and get it done. After setting, you can stripe it out. Temporary structures to support the fresh concrete until it is strong enough to support itself and applied loads. To produce a concrete member, production of concrete members is required of required shape and size. You need this formwork, the supporting structure, the temporary structure. To produce the desired finish of the concrete, also, you need a smooth, suitable formwork. Desirable as a mold or box, concrete form is used as a temporary structure to support fresh concrete until it is strong enough to support same point. Okay. This one I will explain to you later, the requirements, everything. Quickly go through this video and we stop today. And then can you hear the noise? Sorry, sound?
No.
No.
Okay. You need to. I think there is no explanation, but anyway, better hear it. Otherwise, it's a silent video. Today, no, I don't, because I didn't cover. I cannot give you the formwork. Have you all done the quizzes on D Foundation 2? Have you done it?
Which one?
D Foundation 2. Quizzes on D Foundation 2 last class. I told you to do it.
No.
Have you done it? You have done. That's the result I showed to you. Yeah, you have done. We done in the class. What? Can you see the video?
Yes, miss.
Very
Yes,
nice.
miss.
Yes.
I'm giving you the form before I explain it.
Voice not coming. Hello.
There is no voice, there is no speech. It's only animation view how the form work is done. Okay. Yes.
Quiz today.
There is no.
Quiz today.
Today I cannot organize quiz because I didn't complete the lesson today. Sorry.
And then what about the attendance?
Attendance I downloaded.
Okay.
After, just hold on for a while. If you have time, right? Another 4 hour time. Just this video is for 2 minutes only. Please have a look on the video. With that, I stop the class for today. No quiz. Attendance I already downloaded. Please be informed. Okay. Just watch. Listen to this video. Listen to this video. Huh? Two minutes only. It's only 2 minutes. Only for 2 minutes. Shall I post the video? Somebody maybe. Can I post this video? Can you all watch and come for next class? Okay.
Okay.
Good. It's better.
Okay, miss.
I cannot even hold you
The
for
video
long.
very lag, miss.
Video. I will
Video
post
very,
it.
very.
Yeah. I will post the video now. All of you go through. I stop here for the class today. Any question you can ask me by message or email, or come to the class early to attend some of the questions. Bye.
Okay, thank you, miss.
Thank you, miss.
You're welcome.